So we can write iterated integrals with different orders of integration other than z, y, x. So let's look at this example. We have this solid bounded by these four surfaces, and we want to write iterated integrals with the standard ordering, z, then y, then x, and then these two non-standard orderings. So let's draw some pictures and then write these iterated integrals. Okay, so here's the solid formed by those four surfaces. And we want to find the surface that's above, the z surface that's above this region, the solid, and below. And that's z equals 0 and z equals 4 minus y squared. So those are our bounds, which are potentially functions of two variables. And that's our first integral. Then, once we've done that, we think about the shadow in the xy plane. That's this little triangle here. And we think about what's the curve in terms of y that bounds this region above and below. Let's move this integral over a bit. Okay, so we have a curve here. That's y equals 2x. And then we have z equals 0. And solving for y in this equation, the intersection of this surface and the z equals 0 surface is y equals 2. So this upper curve is y equals 2. So those will be our next bounds. Y equals 2x to y equals 2. And then we think about what happens to x. What are the range of x? And x goes from 0 to 1. If we look at the intersection of those two curves, they intersect at 1, and the left endpoint of that region in the xy plane is 0. So x equals 0 to x equals 1. And that's our standard ordering. Let's do another one. So this time we're going to have dy, dz, dx. So let me draw the picture. So this first integral has to be surfaces y in terms of x and z. So we need to solve this blue surface for y. We get y equals the square root of 4 minus z. And then that's going to be our upper surface. That's the surface that's farthest from the xz plane. You know, if we're along the y-axis, it's the surface that's furthest along the y-axis. And then the other surface, the surface that's closer to the xz plane, is y equals 2x. So that'll be our lower bound. Okay, two surfaces, the purple surface, which is the lower one, and the blue surface, which is the upper one. So now we're in this xz plane. The upper bound here is the intersection of z equals 4 minus y squared and y equals 2x. So this is going to be 4 minus 4x squared. That's going to be the upper bound. And then the lower bound is z equals 0. So let's move this integral over. Get a little more space. Z equals 4 minus 4x squared, and z equals 0. And then x goes from 0 to 1, like before. So let's continue on to our last ordering, which is dx, dz, dy. So in this ordering, our first integral is going to be x in terms of z and y. So the lower surface in the yz plane is x equals 0. And the upper surface is x equals 1/2 y. Then we're in the dz, dy plane. Let's draw that over here. So we're looking at this parabola. Here, this region here. And the upper bound is going to be Well, it's going to be z equals 4 minus y squared, and the lower bound is going to be z equals 0. And then y is going to go from 0 to 2. Just looking at that picture. And that's our last ordering. All right, that's it for this lecture. I'll see you back here for the next one.